In this and the next two videos, I want to show you why this statement is true. All right, this statement says that if f is a function from the natural numbers to the power set of the natural numbers, then f is not onto. Now you can take that to mean that if f is any function from with domain the natural numbers and target the power set of the natural numbers, then f is not onto. Okay, now notice that I don't say anything about the rule for f in the statement here. Okay, we will see why this is true with a couple of different rules, and in the first with one rule in the first video, this part A right here, and in part B we'll see why this is true with another rule, and then we'll see why it's true in general in part C. But when we're finished, what we'll know is that it doesn't matter what function we have. As long as that function is a function whose domain is the natural numbers and whose target is the power set of the natural numbers, that this function cannot be onto. Okay, so let's start with part A here. Now we've seen this function before. This is from, let's see, Functions 4 worksheet, problem 4, I believe. You looked at this function. Okay, and that, in that worksheet, you didn't have each of these infinite bit string representations of these sets, but I've drawn those in here because that's ultimately the point of everything here, is the fact that we can write each of these, we can write every set, every subset of the natural numbers using an infinite bit string representation, and then also the absent bit string rule guarantees that there's given any list, we can always find one that's not in the list. All right, so let's jog our memory with what this function does. Okay, so this function, so here's our domain, here's our target. Let's see, remember it sends 0 to the set containing 0, 1 to the set containing 1, 2 to the set containing 2, 3 to the set containing 3, 4 to the set containing 4, and so on. Now notice that there's lots of things that don't get hit, right? You could think of this as the range, and notice the dot, dot, dot there. Dot, 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 meaning this goes on and on and on and on and on. And notice that the target is much bigger than the range, right? The range is a subset of the target, right? There's lots of things that don't get hit. All right, so let's see, what's one of them? I think in Functions 4, we saw that this does not get hit, right? The set containing 1, 2. Right, so we have D and E here, and we see that it's not onto. And there's many other choices, right? We could put the set of natural numbers itself. The set of natural numbers is a subset of the natural numbers, and that as well doesn't get hit. Lots of choices here. We could put the set containing 1, 2, 3. This doesn't get hit. The only things that get hit are the subsets of the natural numbers that only contain one natural number. So anything that isn't just one single natural number, any set that contains more than one natural number doesn't get hit. So lots of things don't get hit. But that's not the ultimate point. The ultimate point is that the absent bit string rule is very systematic. The absent bit string rule systematically chooses something not in the range. There's many sets in the range to choose from, but the absent bit string rule is systematic. And it is systematic for any infinite list of infinite bit strings. Okay, now what would the absent bit string rule choose? The absent bit string rule, right, it would go along the diagonal here and it would say, okay, well, let's see, that's a 1, right? That's a 1, so the thing I'm going to, so this is going to be a 0 here, right, in the first position. Okay, now the second position, that's a 1. Okay, so that's going to be a 0. That's a 1, so that's going to be a 0. It's a 1, so that's going to be a 0. That's a 1, so that's going to be a 0. That's a 1, so that's going to be a 0. That's a 1, and that's going to be a 0, and so on. So what we see here is that the absent bit string rule chooses the empty set, which has the infinite bit string representation of 0, 0, 0, 0, 0, 0, 0 on forever. All right. Okay, and another key point is that this is the range, right? The range only goes this is the range. And dot, 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 meaning it goes on forever, but the empty set you can see here is not in the range. And how do we know this is the range, right? Well, each of these has an input, right? Each of those has an input. The range is all the outputs, so therefore this is the range. The empty set does not have an input, right? So it's a D and E here. And so therefore this function is not onto, because we have this D and E here, and we've seen that before. Whenever you have a D and E there, it's not onto.